This video is about one-dimensional motion in the vertical direction. So rather than going down the road, we're now going up in the air or falling through the air. Now this is very similar to one-dimensional horizontal motion. We still have the same 5 variables, VI, VF, ADT, we all need security. Okay, we still have the same 3 equations. First one's missing d, second one's missing final velocity, and the third one's missing time. Alright, so this is all the same for when we did horizontal. Now what's different? When you're dealing with vertical acceleration, or vertical motion, you're dealing with an acceleration of negative 9.81. This happens during free fall. So if something falls, or you throw something in the air, when the only force acting on it is gravity, when the only thing causing it to do anything, to change its direction, is gravity, then its acceleration is negative 9.81. And we say negative because it's in the downward direction. Okay? Now, if you ever forget that number, on your reference table, under your constants, the acceleration due to gravity, lowercase g, is 9.81. So it's negative because it accelerates or gets pushed downwards. Gravity pushes everything towards the ground. So that's number 1 to remember, that your acceleration is 9.81 or negative 9.81. The other thing gets thrown up in the air and comes back down. We separate those two situations. We say, alright, it's going up and then it's coming down. Because it changes direction, we kind of treat it as two different things. So if you're talking about something getting thrown up to its maximum height or highest point, okay, wherever this point is, the top of its trajectory, the top of its path, the velocity is equal to 0. So if you're on your way up, your final velocity, because initial would be down here, final would be here, is 0. If you're on your way down, then your initial is 0 and your final is something else. So wherever you are at your highest point, that's 0. And you have to remember that. It's not going to tell you it in the problem. I'm going to tell you that I threw a ball up with an initial velocity of 2 meters per second and ask you how high did it go. You can find that because you know its initial velocity. Okay, I told you its initial velocity was 2. You know its acceleration is negative 9.81. You know its final velocity, because it went up high. Okay, it went up, so it went up until it reached 0. And I asked you how far it went. You can solve that problem. Even though I only gave you one number in the problem, the other things are things that you know, that you have to be able to pull out from the situation. And this is where a picture oftentimes really helps you. Let's look at an example. A flower pot on the 5th floor windowsill tips over and falls freely. What is the speed of the object at the end of 3 seconds? So I have a flower pot and it falls freely. Now I'm looking at a motion equation. So I've got 5 possible variables, VI, VF, ADT, we all need security. Now I fill in what I know. Well, I've got this wonderful number of 3 seconds. Well, seconds is a unit of time. So t equals 3 seconds. But I need to know 3 things. I need to know 3 and want to know 1. Alright, which means I'm missing something. So let's see, what do I want to know? What is the speed? So I'm looking for my final velocity, which means I need to know either VI, A, or D. I need to know 2 of those 3 things. Well, it falls freely, so my acceleration is negative 9.81 meters per second squared. Okay, so one more thing. I either know VI or D. Well, I don't know how far it fell. I have no idea about that. So my initial velocity I should know. Well, if it just tips over, then it starts with a velocity of 0. So now I know 3 things, and I want to know 1. And I can do that. The one thing that's missing that I don't know and don't want to know is D. D is not involved at this point. So I look for the equation without D. That's this one. So plug it in. VF equals VI plus AT. So VF equals 0 plus negative 9.81 times T, which is 3. And I get a T equal to, a VF equal to 29.43 negative meters per second. Alright, so the second part of the question is how far did it fall? Now, I know everything else, right? I'm not missing any kind of information, which means I could use either of these equations. This one's easier, so I'm going to use D equals VIT plus 1/2 AT squared. D equals 0 times T, so D equals 0 plus 1/2 negative 9.81 times T squared, 3 squared. So D equals negative 44.145 meters. So it fell 44.1 meters. Let's look at another example. A softball is thrown straight up, reaching a maximum height of 20 meters. Neglecting air resistance, what is the ball's approximate vertical velocity when it hits the ground? Alright, so ball's going up and then it comes back down. It went a distance of 20 meters. Okay, so the ball reached a maximum height of 20 meters. Neglecting air resistance, what is the ball's approximate vertical velocity when it hits the ground? So we're looking at it when it hits the ground. So we're looking at it on its way down. We care about this part of the fall, or of the path. So it went 20 meters. But it went 20 meters down. So you want to make sure you get that negative in there. If you don't put that negative in there, you might end up with trying to take the square root of a negative number, which if that ever happens, then you probably forgot a negative for your D. So go back and double check and make sure you have all your negatives in there. Alright, so that's the only number they gave you. So we've got all our numbers covered. But we still need to know more things. So we need to know 2 more things. Well, we're on our way down. So our initial velocity is 0. We're falling through the air, so our acceleration is negative 9.81. Bam, we know 3 things. We're good. Now, we're solving for the velocity when it hits the ground. We're solving for VF. The one thing we don't know and don't want to know is T. So we pick the equation without T. In this case, this one. So VF squared equals VI squared plus 2AD. VF squared equals 0 squared plus 2 times negative 9.81 times negative 20. And we get a VF squared of 392.4. Take the square root and get 19.8. Now, if you had forgotten the negative on that 20, this would have been a negative 392, because then they wouldn't have canceled, right? If that happens, go back and check. You might have forgotten a negative in there, okay? It's not that your number is wrong, it's that you forgot the direction at some point. Okay, that's the end of the lesson. Good luck on your homework.